So next we'll take a look at an exponent applied to a power. So for example, here we have 3 squared, that's our power, but that power also has another exponent to it. Okay, and so if we write this out, this actually looks like 3 squared times 3 squared times 3 squared. Okay, and so we end up having our base stays the same, but each time the base is multiplied by itself. Okay, so as a single power, this is going to be actually 3. There's 6 groups of 3, so and the reason why we have 6 groups of 3 is we add them all together. So here we've got 1, 2, 3. So this actually becomes 3 to the power of 6. Again, if I evaluate 3 to the power of 6, that's going to give me 729. If I look at the next example, I've got negative 2 to the exponent 4 all squared. So this means that I've got negative 2 to the exponent 4 times negative 2 to the exponent 4. So how many times is it being multiplied? Well, if I look through, I've got 4 plus 4. I've got 2 groups of 4. So ultimately, I'm left with negative 2 to the exponent 8. Okay, 2 groups of 4 added together gives me 8, just like 3 groups of 2 added together gives me 6. So if I want to figure out what this is, I get negative 2 to the exponent 8. That's going to give me 256. Okay. So now I've got 1 over 2 to the exponent 3, or 2 is to the exponent 3, and I've got this multiplied 5 times. So this is going to be 1 over 2 to the third times 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 1 over 2 to the third. Okay, and so again, if we want to figure out, well, what's the total number of exponents? We add them together. So I've got 3 plus 3 plus 3 plus 3 plus 3. Well, 3 groups of 3 is going to actually end up giving me a total of 1/2 to the exponent 15. Okay, and so if I do 1/2 to the exponent 15, well, 1 to the exponent 15 is 1, and 2 to the exponent 15 is 32,768. Okay, so by rule of thumb, what ends up happening is you end up with the same base, but in this case, when you have a power multiplied, or a power raised to exponent rather, you end up with the same base, and you take your power, or sorry, your power's exponent multiplied by the outside exponent. In other words, m times n. So when you have a power of a power, you keep the base and you multiply the exponents. Okay? So in summary, what we've done, we've got these 3 exponent laws so far. We'll do a couple more tomorrow or in the next lesson, but they only ever apply again when you have the same base. That's absolutely critical. Okay? So when you have 2 exponents with the same base and they're multiplied, then you add the exponents. So m plus n. When you have two powers that are being divided and they have the same base, you do subtraction. And when you have 2 powers with the same base, so when you have a power raised to an exponent, then you multiply the exponents together. Okay, so those are the 3 exponent laws that we're going to start off with and practice today.